there, so this is Unit Q Concept 5, number 24, and the problem, it appears kind of tricky, but it really isn't. The problem is sine of x in parentheses 1 minus 2 cosine squared x plus cosine to the fourth power x, end of parentheses equal to sine of to the fifth power of x. And this is a verifying problem because you already know where you're going to end up, where you're going to end with. Now we just have to, I'm going to go through the steps of how to get there. So first of all, I know that cosine to the fourth of x minus 2 cosine to squared x plus 1. So I'm just dealing with this part of it right now. And I know that 1 minus 2 cosine squared of x plus cosine to the fourth of x is the same as cosine to the fourth of x minus 2 cosine squared of x plus 1. And so I'm just going to substitute in u because I don't really want to deal with the cosine right now. It just makes things look a lot harder than they really are. So I'm going to substitute the cosine with u. So I have u to the fourth power minus 2 u squared plus 1. And I'm just going to factor that out, and it factors to be negative u squared plus 1, and then negative u squared plus 1 as well. And if you want to check that, you can just fill it out and you'll find it's the exact same thing as this. So then we substitute back in the cosine of x, and we have negative cosine of x, negative cosine squared of x plus 1, and then negative cosine squared of x plus 1. And we know from our identities, the Pythagorean theorem identity, that negative cosine squared of x is the same as 1 minus cosine squared of x, which is equal to sine squared of x. So we're going to substitute that in here and here. And so when we multiply it out, notice how we always add the exponents. So here's a 1, even though it's not there. It's a 1. So 1 plus 2 is 5. So then we have sine of 5 plus x. Look, we got the answer. And if you don't know where I got this from, it was just originally here. At first I was just dealing with this part to make my life simpler. But then I just added it back in here, and there's your answer.